to meet Federal Information Systems Management Act. And it's, that's a broad brush. But then you get into really, what do I care about? How many factors do I need, and how do I package those? How do I protect those, and what do they mean? I have a great example of this. I had an IVR system, a voice recognition system, to change passwords for a benefits application. This is your benefits. Two things you'd never mess with. One is folks' vacation time. The other one is their paycheck. Never mess with either. so you go and you're doing these benefits, and you're like, okay, I've got all this stuff, and I want to change my healthcare or whatever. Or I want to put in my healthcare spending account, and they do it over an IVR system. So they do voice recognition to do it. Well, they weren't protecting the database that the IVR was in, so they had a biometric. It took the longest time to convince these people that was biometric data, that they couldn't just leave it sitting in a DMZ somewhere touched by the internet. And so, you look at that and you go, they go, why do you mean it's biometric data? I'm like, it's something you are. It's your voice. It has why do you think the system uses it? It's a print. So on the policy side, they thought that was a good thing. The auditors were like, we can do that. That's legal. But on the technology side, they're like, well, we don't understand what that's useful for. We don't think it's real. And so there's a big problem there that keeps bubbling up to how you protect that type of data and what you actually consider biometric data. In the top-down model, administrators also use this facility. That was a big thing that I really, that caught me by surprise. So you have a remote administrator out there, and you have a top-down model. And I'll show you in a minute why this is important. You have somebody just going in to user manager and just, changing passwords. None of it gets propagated anywhere to the other applications. So then you get a negative effect of users starting to call up. And so when you do the top-down model, it has to be all or nothing. That's one of the caveats to it. The changes to underlying systems are basically forced down to the systems. And no account management is allowed at the target systems. This has gotten better over the years, but it's still, if you're going to start simple and you want to do user provisioning, this is the way to start, and you basically start with one set of applications that you can trust. Work your way down from there. Hello? Okay. So this is kind of hard. You guys can see it on the screen or not. This is one of those diagrams I had trouble with after they told me about the television requirements. I had to change up everything. But basically, this is, at the top you have Joe user going in. Step 1 is he initiates a password change. And step 2 over there is begin orchestration. So change password equals this password. He's got it in an IDM environment. The way this works is you have to go and retrieve out of the directory Joe user. You have to look at a policy database and figure out what systems that they are relevant to. And then you have to start reaching out to those systems. And some of these systems are not very smart, as the last one. One of the things that your IDM, and the reason I put this in there is because this is another one that caught me off guard. If you are basing identity on a role, so in other words, you have a database and you use role-based access control, I can't change a password for a role, because every time I change the password, someone will get locked out. So, that's one of the systems that you either have to do something very creative and notify everyone of the password change, or you just have to give it up. And generally, right now, what I'm seeing in most systems that I see provisioned is they generally try to stay away from that one. And there's just not adequate, and it might have changed in the last 6 months, but there's not adequate technology from what I've seen. So you retrieve this profile, and then these agents or these other types of technologies start reaching out to these systems and changing the various passwords. And they do it through a transactional model. So they commit on both sides, and then they agree, and they put it in a log. Ton of forensic information, and that's an interesting point. If you've ever tried to track one of these systems, firing all those logs into ArcSight and everything, you're talking about just thousands of lines of data as it goes through, and it tracks all those changes. It's actually fascinating to look at, but and if you have the time, you can dig through it and find everything that happened. But I was asked a few years ago, can you prove that X user went and changed all these passwords on this system? It took about 2 weeks to dig through the data for one single change. It's just like security incident management. I mean, it's a ton of data, and these systems are not smart enough yet to canonize these things up to a level that's abstract them up to a level that's readable through meta tagging or whatever. They basically record everything. So anytime they access something, anytime they get a SID from Windows NT, or they get a UPN hit from Windows 2000, or they get a web, an NCSA weblog saying they logged in, they track all that stuff. It's nice, but really not usable. Reconciliation. This is the one I told you about that I tried first, and it is a good model, and the technologies are getting much better for this model. However, it must be applied sparingly. You're allowed access at the perimeter. So, for instance, a good provisioning model in reconciliation would be pick a reliable one and pick the one that you know is going to change the most, and focus on those systems. So in other words, like your LAN operating system, you have to change your password every 90 days or whatever your policy is. Focus on that one primarily and maybe one more, and you can do reconciliation. But the technology is such with the logging and the actual throughput to back and forth in these transactional engines that these things use right now, that if you try to do much more than that, you really get into a quagmire. I remember when we first tried modeling this, and this was probably 3 years, maybe 4 years ago. It would bring the transaction server for webs, in this case for the web environment, to its knees. I mean, it would just, after about 5 hours, it couldn't keep up with the changes any longer. Again, very resource intensive, and the performance characteristics on this one, what folks want when they change a password. The worst thing to go and try to explain to an IT executive or an IT manager above you is why I changed my password on my LAN operating system and it took 72 hours to propagate to the rest of my systems. That just doesn't fly. They don't want to hear that. This is the age of automation. It's the age of instant automation. So it better happen just like that. And if not, know your limitations and just stay away from that one. It's done through agents meta-directory integration. There's a lot of tools out there that do a wonderful job, but directory-to-directory integration, whether you're Microsoft or IBM or anybody, they all have about the same level of tools. They've come up in the last couple of years. And directory virtualization, which is basically I make remote calls out to a bunch of different directories, and for you, I make them all look like one. So it's sort of like a proxy. It just handles the request for you and then goes and retrieves separate information from separate directories. You need a really good network for that one usually. And so this is the reconciliation model. So you can see it starts down at the target system. I do a user-initiated change. I change my password. The agent in this case has to detect that change. So that's another thing. When you're running this against a network operating system, it has to actually detect the change as it's happening. So it's looking at the event log, for instance, in Windows 2000 and going, Joe user changed password, boom, boom, boom. And then it has to initiate events based on that. That's a dicey process if you've ever done real-time monitoring of a log to initiate an action. Automated response is challenging. So you get up here to number 3, you retrieve the user, retrieve the provision profile, and you begin to reconcile, and you do the same thing you did in the top-down model. You just do it with the knowledge that you're not going to rechange it on the target system. And you would be surprised how that surprises you when you first do this. We did this, and we couldn't figure out for a week why every time we changed our password, within about 5 hours, the password changed again. And you started to create a loop because at the time the engines weren't smart enough to realize that they needed to disable the agent of the system that it originated from. Otherwise, it went back and changed the password, and the whole thing started all over again. Sounds silly, but it happens. So that's when you get back to the development team at the company. You go, did you really think that one through? And they go, because they've got database experts, they've got user interface experts. But there's not a lot, and this is an encouraging thing, there's not a lot of IDM experts out there. There's not a lot of folks who understand the workflow of user entry through user exit of an organization. And it's going to continue to be a big one. Talk a little bit about identity management models as they regard web access management. This is one of the ones you really probably interact with, you just probably don't know it. I've used this one as it's a wonderful amount of technology, but it's really sort of anticlimactic when you see it. Because generally when you see it, I use one name and password and I get to all these different websites. And anybody used Microsoft Passport? All the IA guys are going, no way. Well, Passport was like an attempt to do this, but it really is one of those things that's it doesn't show you a lot. If it works, it's great. If it doesn't, then you get lost somewhere and you have no idea how you got there. So the installed programs translate requests to manage normalize access management rules. This is a big one.